Okay. I said in this example we are just going to do an example for our angle. We are told that a certain star is in upper transit. It's in upper transit at 6:30 p.m. and then we are asked to find the hour angle at 10:15 p.m. 10:15 a.m. The next day. So basically, let me draw my sphere. Let me draw my sphere for it to be easy to explain. So imagine this is the what? This is, I'm just going to call it the south celestial pole, and here I'm going to put the what? The north celestial pole. And this is going to be my celestial axis, and I'm going to draw my celestial equator like this, and it goes right at the back, and this is going to be my center C, and this is going to be my origin, because this is the zenith, the nadir, therefore the horizon is here. That's where the horizon is. So this is the point that is above the horizon. So therefore that point is what is going to be my origin. We are told that a certain star is in upper transit at 6:30 p.m. That's what we are told, right? It's at 6:30 p.m. So upper transit, we know upper transit occurs when what? When that star crosses the observer's celestial meridian. So this is the celestial meridian. So it means at 6:30 p.m. it was crossing the what? The celestial meridian. Let's just imagine the star to have been there at 6:30 p.m. This is where the star was at 6:30 p.m. It's what? It's upper transit. Now, since this side here is going to be my eastern side, and then that one is going to be my western side. Let me just say that is my western side, that is my eastern side. This star, as this celestial sphere rotates from east to west, as it rotates from east to west to form a new day, this star will go to the back of the sphere, 7 p.m., 8 p.m., 9 p.m., 10 p.m., 11, 12, 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, it will be now on the front side here. It will have gone round because it has gone round like this. So now imagine that the star is now here at 10 p.m. So what we do is we draw a what? An hour circle like that, right? That's what we would have done. We would have drawn an hour circle like that, and then M would have been there. And we would have wanted to calculate what? To calculate our angle OCM, because OCM is our what? OCM is equal to our angle. That's the way we would have done it. But the problem is drawing the hour circle and saying OCM is our angle will not help us in this case. I just wanted to demonstrate what this star is doing. It's going right at the back and then coming in front here, and then we draw our hour circle like this, and just linking it to M, and then doing our OCM. Here we are going to use time, because you know there's a relationship between degrees and time. So we are going to use that relationship. How many minutes or hours has it passed upper transit, or how many minutes has this star gone through from 6:30 to 10:15 a.m. That's what we just need to calculate. So from 6:30 p.m. to 10:15 a.m. the next morning, this is equal to 15 3/4 hours. This is easy for you to calculate. You can just calculate or even count your fingers from 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, just to get what? To this 10, you can convert it to 22 if you want to make it easier. You can convert it to 22, to say 22, 15, and 6:30 minus 6:30. Here you get your nice 45 minutes, and here you get your nice 15 hours. So it is 15 hours 45 minutes from 6:30 p.m. to 10:15 a.m. the next day. You can calculate it whichever way you want. What is interesting now is we are going to use this number of hours to calculate the hour angle, because upper transit occurs when the hour angle is equal to 0, right? Our upper transit occurs when our angle is equal to 0, because can you see, upper transit is when this is on the celestial meridian, but the hour angle of a celestial meridian is equal to 0 because it coincides with the origin. As you can see, it coincides with the origin. So when it's in upper transit, the hour angle is equal to 0. That's one thing you now need to know, that at upper transit, the hour angle is 0 degrees. And I've just given the explanation that upper transit occurs when what? When this is on the celestial meridian. And this hour angle of a celestial meridian is 0 because the celestial meridian is cutting the origin. When it cuts the origin, the origin's hour angle is 0. So the upper transit always has an hour angle of 0. So when you want to calculate the hour angle, we are just going to calculate, okay, it has passed through so many hours. So those so many hours that have been added are degrees that have been added onto 0. So let's calculate the degrees added and add them to 0. That will be their final hour angle. So converting this to hour converting these to what? To degrees. We know that 24 hours they make what? 360 degrees. Therefore these 15 full hours, 15 hours, if you remember my video of conversion, this is basically what I'm doing. It's 15 hours over 24 hours equal to, or multiplied by 360 degrees. This will give me 225 degrees. Okay, so I've converted the 15 full hours. Let me convert the 3/4 of an hour to degrees as well. So if 24 hours are 360 degrees, what about the 3/4 of an hour? 3/4 of an hour, I will do 3/4 over 24 multiplied by 360. In this case, I get 11.25 degrees. That's what I get, 11.25 degrees, right? So 11.25 degrees, I can now say, okay, these are 11 full degrees. These are 11 full degrees, right? And a decimal of a degree is no longer a degree. They are now arc minutes. Decimal of a degree are arc minutes. So I can now say, all right, I have my full degrees. Let me put them on the side. Let me convert these decimal degrees to minutes. So it's a 0.25 of a full degree. We know that a full degree has 60 minutes in it. So here we multiply by 60 to get the total arc minutes of 0.25. To get the arc minutes of 0.25. The arc minutes of 0.25 will get 15 arc minutes. So basically, this 3/4 of an hour, it is equal to 11 full degrees and 15 arc minutes. Now we have converted both of these things, so we can add this and the 11 and a 15. Now I do not have space, so I'm sorry, I'm just going to squeeze here. I think my papers, I didn't rub off my paper, so I'm just going to squeeze there. This is going to be 225 degrees plus 11 degrees 15 minutes. When you do the maths, you get 236 degrees 15 minutes. That is the hour, that is the degrees that have been gained from upper transit, from the point where it was. But now we know that originally the hour angle was 0. So the final hour angle is going to be the original hour angle plus the degrees that have been gained. So the final hour angle is 0 plus 236. So therefore the final hour angle is just going to be 236 degrees 15 minutes. So that's how you get this this hour angle at what? At 10:15 a.m. I hope you've understood these examples. In the next video, we are going to go into the second part. The second part of our coordinate systems. We are going to do the second equatorial system. The problem with this, with the first equatorial system, it is because it uses something that is constant, declination, but it uses something that is not constant, hour angle, because as we noticed, our angle increases with what? When the celestial sphere is rotating. In our previous example, we saw that at 10:15 it will have a different hour angle. So it basically means I cannot tell someone exactly where the star is, because if I tell the person now, if I send an SMS now at 12 a.m. and say, my friend, at 12 midnight, I say see the star that is at declination this and our angle 2 degrees. When the person gets the SMS at 1 a.m., they are not able to see because the hour angle has changed. So we need something at least that is consistent. The declination S might be the same, but now the hour angle has changed. It has moved. A new star now has the hour angle of what? Of that 2 degrees that I told my friend about. And then when the friend wakes up, they'll be like, Easton, why are you waking me up for this boring star? It's not even interesting. It's just because the star that I wanted to tell them about now has a new hour angle because of the rotation of this celestial sphere. So that is the problem with this system. This part here, well and fine. This part here, not so fine because it moves with that with time. So that was the reason for this second dictatorial system. We are going to see that in the next video what it's all about.